Okay, so hello guys, this is section 14.3 video 2. In the remaining examples of section 14.3, we're going to focus first about factoring quadratic equation, which is polynomial of degree 2, ax squared plus bx minus c. So we're going to talk about the examples when the coefficient c it's negative and coefficient b, the one which is in front of x, will be positive. So let's write a note. So in this case, when c it's negative and b it's positive, okay, then two integers will have different signs. One will be positive and the other one negative. So you can have positive, negative, negative, positive. Okay, so let's solve examples. So we need to factor 2w squared plus 5w minus 3. So a is equal to, b is equal 5, c is equal negative 3. So again, we have negative c, b is positive. That means the two integers which we'll find will have opposite sign. One will be positive, one will be negative. So we're going to factor this out using AC method. Okay. So first I multiply a times c. So we're having 2 times negative 3. We end up with negative 6. We need to find two integers, which by multiplication will give you negative 6. And the same two integers by addition has to give you b, which is 5. Okay, so let's see what's going to work. We already know that one integer will be positive, one will be negative, because c is negative and b is positive. So that's another good fact about AC method when you need to find those integers. 6 and negative 1 will work. 6 times negative 1 is equal to negative 6. 6 plus negative 1 will give you 5. So 6 is positive, negative 1 is negative. So next what we need to do, rewrite as a w in this case plus first integer times aw plus second integer. Okay, again we have quadratic equation w to a second power, so you're putting aw in each parenthesis. So in our case, again, a was equal to, so we're going to have 2w plus 6 times 2w plus negative 1, which we can put just 2w minus 1. So plus 6, and the second integer was negative 1. Okay, don't forget that we need to factor out GCF from each parenthesis. Okay, so this is not a final answer. That's not the final factors. Okay, very important. So we have 2w plus 6 GCF here. It's equal to, so we're going to factor 2 out. So 2w divided by 2 will give you w. 6 divided by 2 will give you 3. And we ignoring that GCF, we're skipping. Okay, so we only keep w plus 3. And I'm going to do the same thing with the second group, which was 2w minus 1. In this case, GCF is equal 1. So when GCF is equal 1, you keep your original. 2w minus 1. So there's nothing to skip it. Okay, so the final answer will be okay, w plus 3 times 2w minus 1. Okay. Okay, so we did it. And let's just do more. Another example. Example 4. Factoring higher degree polynomial. So I teach you how to do it. Again, like you see that section, technically, it's reviewing what I did in previous section, which is great for review. Factoring higher degree polynomial. Okay, so we're going to have a polynomial which will look like this. A x to the 4 power plus bx squared plus c. We're going to talk about those type of the polynomial. Okay, so how are we going to do it? So let me just write note. So we still will use AC method, but when you find, so again, in this case, there's no way that you can factor GCF out because C doesn't have an X, okay? So when you have X to the 4 power and then X to a second power, so technically the exponents are multiples of 2. So you still can use AC method, but when you find two integers, you will rewrite so you create those two parentheses as, and again, check what happened here. You have ax to the 4 power, so you're going to rewrite that as a and split that x to the 4 power as x squared plus first integer times a x squared, not just ax, because again in this case we have x to the 4 power, so if you will FOIL you end up with x squared times x squared, which will give you original x to the 4 power, ax plus second integer. Okay, then again don't forget that this is not your final answer. Then factor out GCF from each parenthesis and ignore it. So we're going to see how that's going to work. You're going to factor, again, polynomials of degree 4 when you have x to the power of 4 and then x squared. Like you see, the exponents are multiples of 2. You still can use AC method. The only difference is that when you create your factors, you're not going to have an x in each parenthesis. You're going to have x to a second power, because now you're splitting that x to the power of 4 in half. Okay, so let me show you examples. So if you understand that AC method, which I'm talking about it for a long time already, this is the same thing. So let me give you an example. So again, factoring ax to the power of 4 plus bx squared plus c. Let's do first example. 3x to the power of 4 plus 8x squared plus 5. So I still can use AC method since exponents are multiples of each other, multiples of 2. Okay, so how are we going to do it? In this case, a, it's still the leading coefficient, which means the real number in front of x to the highest power. So a, it's equal 3. B, it's equal 8. Okay, that's the middle expression. C, like always, it's number which is by itself. So you follow exactly the same steps for AC method. Okay, so first what we're doing, we know what we need to do. Step 1, multiply A times C. So we're having 3 times 5, we're getting 15. Step 2, so I'm reviewing those steps because there is no change. Find two integers. Which product equal to AC and sum is equal to B. So we're looking for two integers which by multiplication will give you 15. And the same two integers by addition has to give you B, which is 8. Okay, so we already see that A is positive, B is positive, so our two integers, they will be positive. So just note, since A and B are positive, the two integers must be positive. Okay, so what's going to work? Let's see. 5 and 3 works. Okay, and satisfy both conditions. 5 times 3, 15. 5 plus 3 is equal 8. So step 3. Okay. Write 2 parentheses as A, and this is new. Look what happened. Our original problem had x to the 4 power, so you split that. So A x squared plus first integer. That's the first parenthesis, times a x squared plus second integer. Okay, so in our case, this is what we have. A, coefficient A, it's equal to 3. So we're going to have 3x squared plus the first integer which we find was 5. So we have 3x squared plus 5 times 3x squared plus 3, integer 2. Okay, so that's the only difference in this example. When you have polynomial and you need to factor the expression, which is ax to the 4 power plus bx squared plus c. Again, so when you see the exponents which are multiples of 2. Okay, so you're still using AC method, and that's the only change. That in parentheses, when you build those two parentheses, you're going to have x squared in each. Okay, so don't forget, like before, this is still AC method. This is not the final answer. So please remember about that, okay? Because you did all that work and I don't want you to mess up with the last step. We just need one extra step. Okay, so step 4, factor GCF from each parenthesis. Okay, so let's work with the first parenthesis, which is 3x squared plus 5. Here, GCF, it's equal 1. So keep it. Keep it the way it is. Keep it as 3x squared plus 5. Then take the second parenthesis, which is 3x squared plus 3. In this case, GCF is equal to 3. So we're going to rewrite that as 3 times x squared plus 1. Again. And we ignoring. So you have to ignore it. So the only thing what you're going to keep, you only keep the parenthesis, x squared plus 1. So now we have it. We're going to rewrite the final answer using two parentheses, 3x squared plus 5 times x squared plus 1. So step 5. Final answer. Your original equation, 3x to the power of 4 plus 8x squared plus 5 is equal 3x squared plus 5 times x squared plus 1. So like you see, I use AC method. I factor this equation, like equation ax squared plus bx plus c. You're still using AC method. The only change that in each parenthesis you see x to the second power. So we're splitting that power 4 by 2. We're splitting by half. Okay. So let's do one more example, and that will be the final example of this section. Let's do B. So factor 2y to the power of 4 minus y squared minus 15, and note, use AC method. So definitely we can use AC method because look what happened. we have y to the 4th power, and in the middle you have y to a 2nd power, okay? So those powers are a multiple of 2, and you always can use AC method if the middle exponents it's half of the first exponent, okay? So now to use AC method, always when the middle exponent is a half of the first exponent of the highest exponent. Okay, that highest exponent, I'm talking about the first exponent. Okay, so let's do it. So first, what we're going to do, so I'm going to do it without writing steps. Let's multiply a times c. Again, in this case, a it's equal positive 2, b it's equal coefficient in front of middle expression, which is in this case negative 1, c it's equal negative 15. So a times c, we have 2 times negative 15, which is negative 30. And look what happened here. C in this case, let's just write down, let's just talk about it. C it's negative, B it's negative. So when you have a case like that, when C it's negative and B it's negative, our two integers will have opposite sign. So two integers will have opposite sign. So two integers will have opposite sign. Okay, so a times c is equal to negative 30. Find two integers, which we know because b and c are both negative, they need to have opposite sign, which by multiplication will give you negative 30. That's our AC. And the same two integers by addition has to give you b. And in our case, b it's equal to negative 1. So let's see what's going to work. Negative 6 and positive 5 will work. Negative 6 and positive 5. So next what we're going to do, we're going to rewrite as a y squared plus first integer times a y squared plus second integer. Okay, a is equal to, so we're going to put 2y squared and the first integer was negative 6 plus negative 6, so we can just put minus 6 times 2y squared. And the second integer was equal 5, so we're putting plus 5 because it's positive. Okay, so when you have this, don't forget that this is not final factors. Okay, don't forget that next factor out GCF from each parenthesis, if you have one. Okay, so the first parenthesis, it's 2y squared minus 6. So here we definitely have a GCF, which is equal to, so we're going to put 2 in front of the parenthesis, take the first expression, 2y squared, divide by your GCF, we end up with y squared. That's what will be in the parenthesis, y squared. And then take the second expression, which is negative 6, divide by GCF, which is 2, we end up with negative 3. That's what goes inside of the parenthesis. Don't forget that we're using that AC method algorithm, so you're ignoring your GCF. So we only keep only y squared minus 3. So that's the only thing which we're going to keep. Next, let's take the second parenthesis, which is 2y squared plus 5. Plus 5. Here the GCF equal 1. So keep original parenthesis, which is 2y squared plus 5. So all the time when GCF is equal 1, you keep your original. Okay, and we have it. Final answer. Last. Rewrite. 3x to the 4 power plus 8x squared plus 5 s y squared minus 3 times 2y squared plus 5. Okay, so we factor this. Okay, that's it. This is the end of section 14.3. Okay, good luck with studying and doing your homework. Send me a message if you have any questions or if you would like to set up the conference so we can go over the material or go over homework if you need my help. Okay.